Hello friends, today we'll continue our discussions on matrices, that is chapter number 3 of mathematics for class 12. In this section, that is chapter 3 part C, we will solve 5 marks questions and answers, that is majority of them are numerical problems and some formulae. As you know, the syllabus for 2021 has been reduced and we are discussing only the retained part of the syllabus. Matrices revision. We have discussed in detail about matrices in our videos 3a and 3b. Let us revise it very quickly and in short. A matrix is an ordered rectangular array of numbers or functions. The numbers are the entries of the matrix. For example, please see the matrix here. A11, A22, up to A1n form the elements of first row. Similarly, the second row is A21, A22, A2n. And the last row is AM1, AM2 and AMN. The last element is AMN. So we have rows from 1 to M and columns from 1 to N. The numbers or A matrix having M rows and N columns is called matrix of the order of M by N, written as M by N. It is also denoted by A is equal to within square bracket Aij Mn. A matrix of order M and N has M into N elements, Mn elements. Addition of matrix. We can find the sum of two matrices A and B when they are of the same order. That is, the M and N should be same. The result A plus B is same as that of A and B. To find A plus B, add corresponding entries of the matrices A and B. That is, we have to add the corresponding elements or entries of matrices. Subtraction also can be done in similar way. A minus B is obtained by subtracting the corresponding entries of A and B. Fifth one, properties of matrix. Matrix addition is commutative, that is A plus B is equal to B plus A. Matrix addition is associative, A plus B plus C equals A plus B plus C. The brackets are interchanged as shown in this slide. Existence of additive matrix, A plus 0 is equal to 0 plus A, where 0 is a null matrix of the same order. Existence of additive inverse, that is A to A dash is the inverse of A. Sorry, A to the power of minus 1 is the inverse of A. A plus of minus A equals 0, where minus A is the inverse of the matrix. Transpose of the matrix. In transposition, we interchange the rows by columns. That is, a transposition is denoted by transpose matrix is denoted by A dash or A to the power of T. If A equals capital A equals within square bracket small aij m into n, where m is the number of rows and n is the number of columns. Aij is the row number and j is the column number. Therefore, a dash is equal to within square brackets aj n into m. Multiplication of a matrix by a scalar. If A is equal to within big bracket or square bracket, Aij into M suffix M into N is a matrix and K is scalar, then Ka is another matrix which is obtained by multiplying each element of A by K. Types of matrices. We have column matrix with one column, row matrix with only one row, and square matrix where number of rows and number of columns are equal. Identity matrix when diagonal elements of the matrix are 1 and all remaining elements are 0. And zero matrix when all elements are equal to 0. And diagonal elements. A square matrix is said to be diagonal matrix if non-diagonal elements are zeros. So here the difference between the diagonal identity matrix and diagonal matrix is diagonal matrix can have any number in the diagonal and non-diagonal elements are all zeros. Whereas in identity matrix, diagonal elements are 1. Scalar matrix. A diagonal matrix is said to be scalar matrix if diagonal elements are all equal. Next is symmetric matrix. A square matrix is said to be symmetric if A dash is A is equal to A. That is Aij is equal to Aji, small aj, that is elements. Skew matrix. In skew matrix, A is equal to minus A. This is A dash is equal to minus A. Whereas in symmetric matrix, A dash is equal to A. In skew matrix, it is A dash is equal to minus A. The diagonal elements are 0. Inverse matrix. In inverse matrix, if AB is equal to BA is equal to IN, where I is the identity matrix of the order n, then B n into n is called the inverse of A n into n. It is denoted as B is equal to A to the power of minus 1. Inverse of a square matrix, if it exists, is unique. Multiplication. There are multiplication rules and methods of two matrices. Two matrices can be multiplied if m into n, a matrix A m into n with matrix m n into p can be multiplied when the number of column of the first matrix, number of columns, that is n, is equal to number of rows of the second matrix. So here it is row, here it is column. So column of A n should be equal to row of the Bn. The order of the resultant matrix is m into p. That is the first number, that is the row number of rows in the first matrix into the number of columns of the last matrix. This you remember. Here it is only 2 are given. If you have a number of matrices, then the resultant matrix is of the order of the resultant matrix will be the first row, number of first row m, and number of columns in the last matrix. This you please note. Multiplication rule. Row into column. To get the elements Aij of the product matrix AB, we take the ith row of the A and jth column of B. Then we can multiply their corresponding entries and take sum of all these products. These examples are shown in detail in the subsequent worked examples. Matrix multiplication is not commutative. Please note, AB is not equal to BA. Matrix multiplication is not associative. AB into C is associative. That is, AB into C is equal to A into BC. Matrix multiplication is distributive over addition. That is, A into B plus C equals AB plus AC. Second one is A plus B into C is equal to AC plus BC. We have solved this type of problems in the subsequent slides. Next item is if AB equals 0, it is not necessary that A equals 0 or B equals 0. If A, B and C are three matrices such that AB is equal to AC, then it is not necessary that B is equal to C. Then the last item in multiplication is H. If A is a matrix M into N and I is the identity matrix N into N, then AI is equal to IA. Question number 1. if A is equal to within square bracket 1 1 minus 1 2 0 minus 3 3 minus 1 2, B is equal to 1 3 0 2 minus 1 4 within square brackets, and C is equal to within square bracket 1 2 3 minus 4 in row number 1 and 2 0 minus 2 1 in row number 2. Close the square bracket. Find AB, BC and show that AB into C is equal to A into BC. This is a 5 marks question. It is given that, given here 1 1 minus 1 2 0 3 3 minus 1 2. This is a 3 by 3 matrix, that is 3 rows and 3 columns. Similarly, B is given as 1302 minus 1 4, that is 3 into 2, that is 3 rows and 2 columns. And C is having 2 rows and 4 columns. You see, this is first column, this is second column, this is third column, and the last one is fourth column. So we have 3 types of 3 matrices. One of the order 3 by 3, and second 3 by 2, and third one is 2 by 4. We are required to prove AB, find AB, BC and show that AB within brackets into C is equal to A into BC. Let us solve it. So AB is given, A into B. First we will find out AB. It is matrix A is copied here, matrix B is copied here. So as it is, given matrix is written. Next step is AB. We have to multiply AB. So for multiplication, we have to take the row of first matrix and column of the second matrix. First we have to multiply row 1, column 1 and row 1, column 2. Let us do it. So 1 into 1 is 1, plus 1 into 0 is 0, minus 1 into minus 1 is plus 1. So this is given here. Then next row 1, column 2. 1 into 3 is 3, 1 into 2 is 2, minus 1 into 4 is minus 4. Then second row, first column. 2 into 1 is 2, 0 into 0 is 0, 3 into minus 1 is minus 3. Then second row, second column. 2 into 3 is 6, 0 into 2 is 0 and 3 into 4 is 12. It is written here. Next is third row. 3 into third row and first column. 3 into 1 is 3, minus 1 into 0 is 0, 2 into minus 1 is minus 2. And third row, third column, 3 into 3 is 9, minus 1 into 2 is minus 2, 2 into 4 is 8. So you please remember the order of multiplication of two matrices. That is, first row, first column, first row, second column, second row, first column, second row, second column, third row, first column, third row, second column. Thus we have done it. AB, and that we have simplified as 2, 1, minus 1, 18, 1, 15. The next is BC. We have to find out BC in similar way. So matrix B is given here 1 3 0 2 minus 1 4, and matrix C is 1 2 3 4 minus 4 2 0 minus 2 1. We have simply copied both B and C as it is, and now we will perform the row column multiplication. That is 1 into 1 is 1 plus 3 into 2 is 6. Then 1 into 2 is 2, 3 into 0 is 0. 1 into 3 minus 3 into 2, 6. Then 1 into 4 minus 4, 3 into 1 is 3. Similarly, we will do for second row. Second row into first column. Then next is second row into second column here. Second row into third column. Then second row into fourth column. Hence we get 0 plus 4, 0 plus 0, 0, 0 minus 4 and 0 plus 2. This is with respect to second row of matrix B. Now we will take third row of matrix B. Third row. So third row into first column of C. Therefore, minus 1 into 1 is minus 1. 4 into 2 is 8. And third row into second column, minus 1 into 2 is minus 2 plus 0. Then third row, third column, minus 1 into 3, minus 4 into 4 is 8. Then minus 1 into 4 into minus 4, minus 1 into minus 4 is plus 4. 4 into 1 is 4. So we have got all the elements of BC. That will be simplified as 7, 2, minus 3, minus 1, 4, 0, minus 4, 2, 7, 2, minus 11, 8. So this is BC. Next we will find out, we are required to find out, prove AB within brackets into C is equal to A into BC. Now we will substitute the left hand side, that is AB. AB we have calculated here as 2, 1, minus 1, 18, 1, 15. Thus we have copied it here. This is matrix of order 3 by 2. The next matrix is C. C is given. So 1, 2, 3, minus 4, 2, 0, minus 2 and 1. This is matrix of the order of 2 by 4. And the result will be hence 3 into 4. Let us do it. Therefore, AB into C is first row 2 into 1, first column 1 into 2 plus next item is first row second column, that is 2 into 2, 4 plus 0. Then first row third column, 2 into 3 is 6 minus 2. Then first row last column, 2 into 4 minus 8 plus 1. So next we start with second row. Second row first column here. Second row is minus 1. 18 into 2 is 36. It is written here. Then second row second column is written here. Minus 1 into 2 is minus 2. 18 into 0 is 0. Then second row third column. Minus 1 into 3 is minus 3. Minus 2 into 18 is minus 36. It is here. Similarly, we do for all other elements. You please note down and multiply and note down. Next, simplifying this matrix AB within brackets into C, we get 4, 4, 4, minus 7, 35, minus 2, minus 39, 22. That is just summing up and simplifying. 31, 2, 20, minus 27 and 11. Next step is A into BC. We have to find on the right hand side. A, the given vector is written here. 1, 1, minus 1, 2, 0, 3, 3 minus 1, 2. See, this is 3 by 3. That is 3 rows and 3 columns. BC we have found here. 7, 2, minus 3. From here, 7, 2, minus 3, minus 1. 4, 0, minus 4, 2. 7, minus 2, minus 11 and 8. Multiplying, we get first row into first column. Next item, first row, second column. First row, third column. First row, fourth column. So we complete the first row of A into BC. Then similarly, we do for second row, first column. Second row, second column. Second row, third column. Second row, fourth column. We get 4 elements in row 2 of A into BC within brackets. Then finally, the third row of A into BC, we get A, third row into first column. That is 3 into 7, 21, minus 1 into 4, minus 4, and 2 into 7, 14. This is here. Then third row, second column, that is 3 into 2 is 6, minus 0, and 2 into minus 2 is minus 4. It is here. Third row, third column. So 3 into 3 is 9, minus 9, minus into minus plus 4, and 2 into minus 11 is minus 22. And finally, third row, fourth column. 3 into minus 1 is minus 3, minus 1 into 2 is minus 2, 2 into 8 is 16. Now we will simplify it. Simplifying, we get 4, 4, 4 minus 7, 35 minus 2 minus 39, 22. 31, 2 minus 27 and 11. So this is A into within bracket BC. Hence, by comparing this with the previous equation, we get AB into C is equal to AB and AB into C is equal to A into BC. If A is equal to 067 minus 608, 7 minus 80, and B is equal to 011, 102, 120. So matrix A is 3 by 3, of the order of 3 by 3, and B is also of the order of 3 by 3. C is also given, but it is of the order of 3 by 1. That is 3 rows are there and 1 column. Calculate AC, BC and A plus B within brackets into C. So deduce A plus B within brackets into C equals AC plus BC. Solution. A plus B is equal to, it is given, A is given and B is given. We have copied it and we will add the corresponding elements. Corresponding elements are 0 plus 0, 6 plus 1, 7 plus 1. Then minus 6 plus 1, 0 plus 0, 8 plus 2. And the last row is 7 plus 1 and 8 minus 8 plus 2. And the last item is 0 plus 0. So simplifying, we get 078 minus 5, 0, 10, 8 minus 6 and 0. So this is A plus B. We have found A plus B first. Okay. Now we have to multiply it with C. So A plus B we have copied as it is and into C. C is a given matrix 2, minus 2 and 3. So you see here matrix A plus B is 3 by 3 and matrix C is 3 by 1. That is 3 by 3 rows and 1 column. So we can multiply and the resultant will be 3 into 1. Let us do it. So first row is 078. So we get 0 into 2 plus 7 into minus 2 and 8 into 3. First row. Second row is minus 5 into 2 plus 0 into minus 2 plus 10 into 3, 30. The last row is 8 into 2 minus into minus plus 12 and 0 into 3. So we get 10, 20, so now having found A plus B into C, we will find AC. Vector A, matrix A is given and matrix C is also given. So those two have been copied. These two matrices have been copied. So let us do the multiplication. As usual, first row into first column, then second row into first column, then third row into first column. Because there is only one column, so there are only one elements in each row. So we get 9, 12 and 30. Let it be equation 2. Therefore, we get BC is equal to, now we have found AC. We have to find BC. We will copy matrix B as it is. That is 3 by 3. 0, 1, 1, 1, 0, 2, 1, 2, 0. This is matrix B. Then matrix C also we will copy. 2, minus 2 and 3. Now we will perform the multiplication. Therefore, we get 0 into 2, 1 into minus 2, 1 into 3. First element and first row. Then 1 into 2 plus 0 into minus 2 and 2 into 3. That is 6. The second row. In the last row, we get 1 into 2. 2 into minus 2 is minus 4. 0 into 3 is 0. So BC is, we have found 1, 8, minus 2. Let it be equation 3. Therefore, now we are required to prove on the right hand side AC plus BC. Now we will add AC plus BC. That is, AC is equation 2 and BC is equation 3. So here it is written 9, 12, 30 is the AC and BC is 182. We have to add the corresponding elements. Therefore, on the right hand side equal to 9 plus 1 is 10, 12 plus 8 is 20, 30 minus 2 is 28. Let it be equation 4. Now we have to compare with our previous result. That is equation 1. Compare equation 1, that is A plus B within brackets into C, and equation 4, that is AC plus BC. We find that it is 10, 20, 28. Here also it is 10, 20, 28. Therefore, left hand side is equal to right hand side. Therefore, A plus B into C is equal to AC plus BC. Now we will go take up the next problem. Question number 3. If A is equal to, within square brackets, 1, 2, 3, 3 minus 2, 1, 4, 2, 1, show that A cube minus 23A minus 40I is equal to 0. Here, matrix A is given, which is of the order of 3 by 3. We have to find A cube first, and then we have to find a scalar product of 23A. That is, we have to multiply matrix A by 23. Then we have to find a identity matrix which is 40I. So there are 3 steps in all. First find out A cube, then find out 23A, and then find out 40I. Then you perform subtraction, minus 23A and minus 40I from A cube, and prove that it is 0. Let us do it. So first we have to find out A square. So we have copied matrix A here and copied matrix A. That is 1, 2, 3, 3 minus 2, 1, 4, 2, 1. Similarly, we have copied another times. Second time A, to get A square. Please note down. Please note down and write yourself. So first, then we will perform matrix multiplication, that is row column multiplication. 1 into 1 is 1, 2 into 3 is 6, 3 into 4 is 12. We get first element. Then first row, second column. 2 minus 2 into 2 is 4, minus 4. 3 into 2 is 6. Then third item is row 1, column 3. 3 plus 2 plus 3. This is given here. So first row we have completed. Next we move to second row of matrix A. So 3 into 1 is 3, minus 2 into 3 is minus 6 and 4. We get here 3 minus 6 plus 4. Next we get second row, second column, 6 plus 4 plus 2. The next is second row, third column, 3 into 3, 9, minus 2, and 1 into 1 is 1. Then third row and first column, 1 into 4 is 4, plus 2 into 3 is 6, plus 1 into 4 is 4. Then next is 4 into 2, 8, minus 4 and 2. Then last operation is row 3, column 3. 4 into 3 is 12, 2 and 1. So we get a square. And after a square, we have to multiply again with a. So a square is given here after simplification. We get 19, 4, 8, 1, 12, 8, 14, 6 and 15. This is a square given in black color. And in the blue color, we have copied the given matrix A. So it is here. So a square into a. Therefore, a cube is equal to, again, multiplication of matrix, row matrix, row 19, first row, first column, 19, 12 and 32. The next element is first row, second row. So then first row, second column. That is 2 into 19, 38, minus 8 and 16. Then first row, third column. 19 into 3 is 57. 4 into 1 is 4. 8 into 1 is 8. Now we have finished the operation of first row. Then we move on to second row. The second row is 1 into 1 plus 12 into 3 plus 4 into 8. So we have completed this. Next we move to next element, this second row, second column. Therefore it is 2 minus 24 and 16. This is given here. Then again second row, third column, 3 plus 12 plus 8. 3 plus 12 plus 8. Then again third row, first column, that is 14 plus 18 plus 60. It is given here. Then third row, second column, 14 into 2, 28, minus of 2 into 6 is minus 12, 15 into 2 is 30. Then again third row, third column, 14 into 3, 42, 6 into 1 is 6, 15 into 1 is 15. So we have completed multiplication of matrices to get a cube. This will be simplified and written as 63, 46, 69, 69 minus 6, 23, 92, 46, 63 within square bracket. So that is a cube. We have found a cube. Now we will find a cube minus 23a, 40i by substituting the respective values. First we will put this is a cube minus 23 into a we have copied here. This is a 23 into a minus 40 into I. I is the identity matrix. Because previous matrices are of the order of 3 by 3, we have to take I3, I suffix 3. So we have 3 rows and 3 columns for identity matrix I. Therefore, it is 1 0 0 0 1 0 0 0 1. That is identity matrix. The property is all the diagonals are 1. Therefore, diagonal is 1 here, 1 here, 1 here. This is diagonal. The remaining elements are 0. So 0, 0 here. Here in the first, second row, 0, 1, 0. In the third row, it is 0, 0, 1. So now we have to perform scalar multiplication. That is 23 into A and 40 into I. Let us do it. So a cube as it is, we have written minus 23 into 1, 23, 23 into 2, 46, 20 into 3, 69. 20 into 3, 69 again. 23 into minus 2, 46, minus 46. 23 into 1, 23. 23 into 4, 92. 23 into 2 is 46. 23 into 1 is 23. Please note the minus sign we have retained outside only. We have not changed it. Then again minus we have retained outside. So 40 into I. So because ones are there in the diagonal, it will be 1. 40, 40, 40. 40 into 1 is 40. 40 into 1 is 40 and 40 into 1 is 40. So the diagonals will be 40. The remaining elements will be 0. So first row is 40, 0, 0. Second row is 0, 40, 0. Third row is 0, 0, 40. Then we will perform subtraction. Therefore, 63 minus 23 minus 40. First row. Then 46 minus 46 minus 0. Then 69 minus 69 minus 0. 69 minus 69 minus 0. Then minus 6 minus into minus plus 46 minus 40 here in the second item. And then 23 minus 23 minus 0. Then 92 minus 92 minus 0. Then 46 minus 46 and minus 0. Here we get. The last item is 63 minus 23 here and minus 40. It is given. Simplifying, that is, we get 0, 0, 0, 0, 0, 0. So all 0, 0, 0. That is equal to is a null matrix. The sum is 0. Hence, we have proved it. Next problem. Problem number 4. If A is equal to 1, 2, minus 3, 5, 0, 2, 1, minus 1, 1, that is B is equal to 3, minus 1, 2, 4, 2, and 5, 2, 0, and 3, B. And C is equal to 4, 1, 2, 0, 3, 2, 1, minus 2, and 3. All the matrices, given matrices A, B, and C are of the order 3 by 3. This I have written it additional information which is not given in the question, but it is observed from the given data, given problem. So verify, we are required to verify A plus B minus C equals A plus B minus C. That is, we have to perform A plus B operation and B minus C operations. That is simple addition. A plus B is addition and simple subtraction, and from the resultant we have to subtract. This is a very simple problem. You can do it. Therefore, A plus B is equal to A is written here and B is written here. Therefore, 1 plus 3, 2 minus 1, minus 3 plus 2. 5 plus 4, 0 plus 2, 2 plus 5. And the last line, 1 plus 2, minus 1 plus 0, 1 plus 3. So these elements are written here, and we are net result is we get a vector A plus B is equal to 4, 1, minus 1, 9, 2, 7, 3, minus 1, 4. This is also, you see, as observed, it is 3 by 3. Let it be question 1. Again, we are required to perform B minus C, which is given in the left hand side. We have to find from the given matrix B minus C. B is written here, minus C is written here. So let us do the subtraction. Therefore, 3 minus 4, minus 1 minus 1, 2 minus 2, 4 minus 0, 2 minus 3, 5 minus 2. In the last row, 2 minus 1, 0 plus 2, minus of minus is plus 2, 3 minus 3. Simplifying, we get b minus c is equal to, within square bracket, minus 1, minus 2, 0, 4, minus 1, 3, 1, plus 2. Minus of minus is plus 2. And 3 minus 3 is 0. Let it be equation 2. Now left hand side, we are required to find out A plus B minus C. A is a given matrix 1, 2, minus 3, 5, 0, 2, 1, minus 1, 1. It is written here A. Plus is there, and within bracket we have to write B minus C. B minus C is given by the equation 2. Therefore, we have copied this matrix here. That is minus 1, minus 2, 0, 4, minus 1, 3, 1, 2, 0. Therefore, it becomes, we have to add A plus B minus C. Add these two. 1 minus 1, 2 minus 2, minus 3 plus 0. 5 plus 4, then 0 minus 1, 2 plus 3, 1 plus 1, minus 1 plus 2, then 1, 0. These are the elements written. Simplifying, we get 0, 0, minus 3, 9, minus 1, 5, 2, 1, and 1. So we get A plus, within brackets, B minus C equals 0, 0, minus 3, 9, minus 1, 5, 2, 1, 1. Let it be equation number 3. So right hand side is, we are given, we have to find A plus B minus C. A plus B we have found from equation 1. C is a given matrix here. So let us write it. Therefore, it is copied as it is. 4, 1, minus 1, 9, 2, 7, 3, minus 1, 4. This is as it is, we have copied from equation 1. Minus is asked in the question. C is also given. C is written as 4, 1, 2, 0, 3, 2, 1, minus 2, 3. See, I have written the C in blue wing, that indicating that it is a given in the question. So this is, we have derived, and A plus B we have found, and we have to subtract C from A plus B. Therefore, we have to do simple subtraction of two matrices. 4 minus 4, 1 minus 1, minus 1 minus 2, 9 minus 0, 2 minus 3, 7 minus 2, 3 minus 1, minus 1 of minus into minus 2, that is plus 2, then 4 minus 3. Simplifying, we get 0, 0, minus 3, 9, minus 1, 5, 2, 1, and 1. This is equation 4. Comparing left hand side equation, that is A plus, within brackets, B minus C, whose result is given in the equation 3, and right hand side is, within brackets, A plus B minus C, whose result is given in equation 4, we find that both are same. Hence, left hand side is equal to right hand side. We will take the next problem now. Equation number 5. Here, matrices A and B are given. We are required to find 3A and 5B. That is, scalar multiplication of A by a factor 3, scalar quantity 3, and we have to find phi b, that is scalar multiplication of phi with matrix B. Let us do it. It is a very simple problem. Most probably it will be asked in your examination. Only thing is here there are certain ratios. Okay, don't go to calculate fractions. You retain ratios as it is. Therefore, we will find 3a. 3a, 3 into a as it is we can write. Copy from here. 3 is outside. A minus 5. Minus 5 is written here. B is copied from here. Therefore, 3a minus b is given. Please note down and practice. Therefore, we get 3 into 2 by 3 is 2. 3 into 1 is 3. 3 into 5 by 3 is 5. 1 by 3 into 3 is 1. 2 by 3 into 3 is 2. 3 into 4 by 3 is 4. 3 into 7 by 3 is 7. 3 into 2 is 6. 3 into 2 by 3 is 2. So we have found this is 3a. From 3a, you have to subtract 5b. Let us do 5b in the similar way. 5 into 2 by 5 is 2. 5 into 3 by 5 is 3. 5 into 1 is 5. 5 into 1 by 5 is 1. 5 into 2 by 5 is 2. 5 into 4 by 5 is 4. 5 into 7 by 5 is 7. 5 into 6 by 5 is 6. 5 into 2 by 5 is 2. So we have found 3a minus 5b. Now we have to subtract. We have to perform the subtraction operation. Therefore, 2 minus 2 is 0. 3 minus 3 is 0. 5 minus 5 is 0. 1 minus 1 is 0. 2 minus 2 is 0. 4 minus 4 is 0. 7 minus 7 is 0. 6 minus 6 is 0. And 2 minus 2 is 0. So you remember scalar multiplication. You have to simply multiply each element of the respective matrix by the factor. In this case, we have to multiply A with 3 and B with 5. So simple scalar multiplication as indicated. And then we have to subtract. So you find the final matrix and subtract from the corresponding elements. Subtract first element of 5b from 2a and then subtract second element of row 1 from the second element of 3a. So you will get the result. It is a very simple problem. Definitely it will be asked because this year examination is going to be very simple. Let us take up the next problem. That is problem number 6. If a is equal to, it is given 2, 0, 1, 2, 1, 3, 1 minus 1, 0. Find a square minus 5a plus 6i. So please examine, read the question. We are required a is given, vector matrix a is given. We have to find a square. And then we have to find a scalar product of 5a, that is 5 into a. And then 6i. I is the identity matrix. Okay, let us do it. This is also a very simple problem. This can also be asked in the examination. So a square is a into a. A is a given matrix and then again repeatedly multiplied. So we have to multiply. Matrix multiplication has to be done. That is row with column. When multiplication means row with column. Let us do it. That is 2 into 2 4. 0 into 2 0. 1 into 1 is 1 here. Then 2 into 0 is 0. 0 into 1 is 0. 1 into minus 1 is minus 1. This is given here. Now next element. 2 into 1 is 1. 0 into 3 is 0. 1 into 0 is 0. So the 3 elements we got in the first row. Now we have to take the second row and first column. 2 into 2 is 4, 1 into 2 is 2, and 3 into 1 is 3. This is written here. Then second row, second column. 2 into 0 is 0, 1 into 1 is 1, and 3 into minus 1 is minus 3. This is written here. Then second row, third column. That is second row, third column is here. 2 into 1 is 1, 1 into 3 is 3, 3 into 0 is 0. Then last final column, that is third row. 1 into 2 is 2, minus 1 into 2 is minus 2, 0 into 1 is 0. So it is written here. Next element is 1 into 0, that is third row, second column. 1 into 0 is 0, minus 1 into 1 is minus 1, and 0 into minus 1 is 0. Then third row, third column. 1 into 1 is 1, minus 1 into 3 is minus 3, 0 into 0 is 0. Therefore, we have found a square. Now, in the given equation, we will do the subtraction. That is a square minus 5a 6i is the given equation which we are required to find out. Therefore, a square we have calculated. You can calculate 4 plus 1 is 5, 0 minus 1 is minus 1, and this is 2, and this is 4 plus 2 is 6, plus 3 is 9, 1 minus 3 is minus 2, 2 plus 3 is 5, 2 minus 2 is 0, 0 minus 1 plus 0 is minus 1, 1 minus 3 is minus 2. Minus of 5a is asked in the question. So minus 5 we have written outside. A we have copied as it is from the given equation. That is 2, 0, 1, 2, 1, 3, 1 minus 1, 0. So this is a 3 by 3 matrix, and this is also 3 by 3 matrix. So our identity matrix also has to be 3 by 3. Therefore, we add plus 6 into identity matrix mean it is a square matrix with diagonal elements as 1. So here you see 1, 1, 1. All the remaining elements are 0, 0, 0, 0, 0, 0, 0. So we have to do the addition or subtraction as the case may be. Therefore, 5 into 2, this as it is we have copied first item. 5a is minus of 5 into 2 is 10, 5 into 0 is 0, 5 into 1 is 5. 5 into 2 is 10, 5 into 1 is 5, 5 into 3 is 15. Then 5 into 1 is 5, 5 into minus 1 is minus 5, 5 into 0 is 0. So we have found 5a in this matrix, that is second matrix. And finally, we have to have 6i. 6i is simply, we have to multiply 6 into 1 is 6, 6 into 1 is 6, and 6 into 1 is 6. That is, all the diagonal elements are 6. Remaining elements will be 0, 0, 0, 0, 0, 0 in case of identity matrix. Therefore, we have to perform subtraction and addition. 5 minus 10 plus 6. It is here. Minus 1, minus 0, and minus 0. Plus 0. That is minus 1. 2 plus 2 minus 5 plus 0. 9 minus 10. Here 10 and 0. Minus 2, minus 5 and plus 6. Then the last element is 5 minus 15 plus 0. 0 minus 5, 0. Minus 1 plus 5 and 0. Then the last element is minus 2, minus 0 and plus 6. These are the elements we will simplify. So it becomes 1 minus 1 minus 3 minus 1 minus 1 minus 10 minus 5 4 and 4. This is the value of a square minus 5a plus 6. That is the answer. Problem number 7. If a is equal to 102, 021, 203 within square brackets, prove that a cube minus 6a square plus 7a plus 2i equals 0. Given a is equal to 102, 021, 203 as it is. So we have to find a cube. So we will multiply and first find out a square. A is the given matrix here, and this is a into a square. Therefore, a square after multiplication we get 508, 245 and 803 by the usual row column multiplication. Then a square we have to multiply with another a. Therefore, a cube is equal to a square into a. Therefore, the previous matrix 508, 245, 8013 within square brackets is multiplied by another square matrix 102, 021, 203. So we get row column multiplication, that is 5 plus 0 plus 16, then again 0, 0 and 0. Then first row, third column is 10, 0, 24. Second row, first column 2 plus 0 plus 10. Then second row, second column 0, 8, 0. Then second row, third column 4 plus 4 plus 15. We get. Then third row, first column 8 plus 0 plus 26. Then again third row, second column 0 plus 0 plus 0. Third row, third column 16, 0 plus 39. Simplifying, we get a cube is equal to 21, 0, 34, 12, 8, 23, 34, 0 and 55. Again, therefore, LHS, we are taking LHS, a cube minus 6a square plus 7a plus 2i3. So we get a cube. A cube we have taken from here 21, 0, 34, 21, 8, 23, 34, 0, 55. Then minus 6a, 6 into the given a square. Here we have found a square 508, 245 and 8030. Then plus 7a, 7 into the matrix 102, 021, 203. Then 2i3, that is 2 into identity matrix 100, 010, 001. Because the previous matrices are 3 by 3, this identity matrix is also of the order of by 3. So here next step is to do scalar multiplication. So after doing scalar multiplication, we get the value shown here. The next step is to add or subtract as the case may be. 21, 30, 21 minus 30 is minus plus 7 and 2. So we get first two matrix, these two we do it. So 21 minus 30 is minus 9. 0 minus 0 is 0. 34 minus 48 is minus 14. 12 minus 12 is 0. 8 minus 24 is minus 16. 23 minus 30 is minus 7. Minus 34 minus 48 is minus 14. 0 minus 0 is 0. 55 minus 78 is minus 23. So we have simplified the first two matrices, that is a cube minus 6a square. The next two matrices also similar operation, but here addition. So 7 plus 2 is 9, 0 and 14. The second row is 0 plus 14 plus 2, 16 plus 7. And third row is 14, 0 and 23. This is shown here. Again, we have to add up these two matrices. Therefore, we get, if we add minus 9 plus 9 is 0, 0, 0, minus 14 plus 14 is 0, 0, minus 16 plus 16 is 0, minus 7 plus 7 is 0, minus 14 plus 14 is 0, 0, 23 minus 23 plus 23 is 0. We get answer as 0. Therefore, that is equal to right hand side. Problem number 8. Express matrix B is equal to 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Find the sum of symmetric and skew symmetric and skew symmetric matrix. At this stage, I request you to study the definition of symmetric matrix and skew matrix, which was discussed in our video 3a, as well as in the beginning in the revision also we have mentioned about these matrices. We will take up the example numerical problem on this symmetric matrix and skew matrix. Let us start. Given matrix is written here: 2 minus 2 minus 4 minus 1 3 4 1 minus 2 and minus 3. It may be seen that it is a 3 by 3 matrix, though it is not given in the problem, but we have written it for your information. Therefore, B dash, we have to find the transpose. Transpose means interchanging the rows with column. So we will write B dash, the transpose of matrix B, as row is 2 minus 2 minus 4 and written is a column. So 2 minus 2 minus 4. The second row of B is minus 1 3 4. So this will be converted into column. Therefore, it is minus 1 3 4. The third row is 1 minus 2 minus 3. This will be written as a third column, 1 minus 2 minus 3. Thus, we have transposed matrix B into B dash. Therefore, by definition, symmetric part of B is given by B is equal to half of B plus B dash. We know B here and B dash here. So, let us do it. Therefore, we will write half outside and B will write 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus. This is matrix B plus B dash. Plus B dash is, we have found B dash here. Therefore, 2 minus 1 minus 2 3 minus 2 minus 4 4 plus 3. The black color is B dash and blue color is B. This is for only for your information. I mean easy identification. Therefore, we write half of this plus 2. 2 plus 2 is 4. Minus 2 minus 1 is minus 3. Minus 4, 1 is minus 3. Minus 1 minus 2 is minus 3. 3 plus 3 is 6. 4 minus 2 is 2. 1 minus 4 is minus 3. Minus 2 plus 4 is 2. Minus 3 plus minus 3 is minus 6. Now we have to multiply by a scalar quantity half, that is outside the matrix. Now we will multiply. If we multiply 2 by 4 by 2 is 2, minus 3 by 2, minus 3 by 2. So these two elements. This is also minus 3 by 2. 6 by 2 is 3. It is given here. Therefore, 2 by 2 is 1. It is written here. Therefore, minus 3 by 2 and 2 by 2 is 1 here. Minus 6 by 2 is minus 3. Now we have found already in equation 1 the symmetric part of B. This is the symmetric part of B. You have to remember B is equal to half of B plus B dash. Next step. And next is skew symmetric part of B, which is given by definition as B is equal to half of B, matrix B minus B dash. Please remember this. Now we will do the calculation for B minus B dash. We know B is given and B dash we have found. Therefore, half of within big bracket, square bracket, inside is a square bracket. B is copied as it is. Whatever is given, it is written here, minus B dash we have found here. So we will copy it here. B dash we will copy here. 2 minus 1, 1. Minus 2, 3 minus 2. Minus 4, 4 minus 3. We have copied it. Now we have to perform simple subtraction of B dash from B and perform scalar multiplication with the factor with the number 1 by 2. Let us do it. Therefore, that is equal to half of 2 minus 2 is 0. Minus 2 minus 1 is minus 1. Minus 4 minus 1 is minus 5. Minus 1 plus 2 is 1. 3 minus 3 is 0. 4 minus into minus 2 is plus. So it becomes 6. 1 minus of minus 4 is 4 plus 1 5. Minus 2 minus 4 is minus 6. Minus 3 minus into minus plus 3 is 0. Now for this we have to multiply with half. So that we will do in this part. Therefore, this is 0 divided by 2 is 0. Minus 1 by 2. Minus 5 by 2. And 1 by 2. This is 1 by 2. This is 0. 6 by 2 is 3. It is written here. This will be 5 by 2. And minus 6 by 2 is minus 3. And the last part is 0 by 2 is 0. Let this be equation 2. Therefore, now we have got from equation 1, we got half of B plus B dash. This is half of B plus B dash, and from equation 2 it is plus half of B minus B dash. So we will add equation 1 plus equation 2 and verify whether B is equal to. So these two are added to find the value of B. Therefore, adding 2 minus 3 by 2 minus 3 by 2 minus 3 by 2 3 plus 1 minus 3 by 2 1 minus 3 plus 0 minus half minus 5 by 2 half 0 3 5 by 2 minus 3 0. This is the value of half of B minus B dash, and this is B half of B plus B dash. Therefore, we get 2 minus 2 minus 4 minus 1 3 4. 3 plus 1 is 4. Minus 3 by 2 plus 5 by 2 is 1. 1 minus 3 is minus 2 and minus 3. If you compare this, 2 minus 2, 4 minus 4, 1, 3, 4, 1 minus 2 minus 3. This is same as B. Hence, that is equal to B. Hence, we have proved that B is equal to half of B plus B dash plus half of B minus B dash. Next problem. Express matrix A 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3 within square brackets as the sum of a symmetric and skew matrix. So let us note. So previously also we have seen, but we had not written this formula. Every square matrix A can be expressed as the sum of a symmetric matrix, half of A plus A dash, and skew symmetric matrix, half of A minus A dash. So we have to express it. This is a given matrix. 6 minus 2, 2. Minus 2, 3, minus 1. Please copy down along with me. 2 minus 1, 3. Therefore, A dash is equal to A dash. We have to transpose. A dash is the transpose. Interchange row with column. So 6 minus 2 row 2. It is a row 1 and it becomes in the transposed matrix it is becomes column 6 minus 2 2. Similarly, row 2 minus 2 3 minus 1 becomes column 2 minus 2 3 minus 1. Then row 3, 2 minus 1, 3 becomes column 3, 2 minus 1, 3. So, matrix A has been transposed to matrix A dash. Now we have to perform half of A plus A dash and half of A minus A dash. Half of A plus A dash will be symmetric matrix and half of A minus A dash will be skew symmetric matrix. So let us do it. Symmetric part. Therefore, it becomes half of A, this is the given matrix, plus A dash. Copied from the above two equation. This is from equation 1 and this is from equation 2. So, combining, we get half of 6 plus 6 is 12. Minus 2 plus minus 2 is minus 4. 2 plus 2 is 4. Minus 2 minus 2 is minus 4. 3 plus 3 is 6. Minus 1 minus 1 is minus 2. 2 plus 2 is 4. Minus 1 minus 1 is minus 2. 3 plus 3 is 6. So, the factor half is there outside. So, we have to multiply with half. So, it becomes 12 by 2 is 6. Minus 4 by 2 is minus 2. 4 by 2 is 2. Minus 4 by 2 is 2. 6 by 2 is 3. And minus 1. 4 by 2 is 2. Minus 2 by 2 is minus 1. And 6 by 2 is 3. This is the symmetric part and let it be equation 1. Now we will find skew matrix part of A, that is equal to half of A minus A dash, where A is the given matrix and A dash is the transposed matrix. Therefore, writing and substituting the values half as it is, A is copied from the given equation minus A dash we have calculated here. So the values are written here. I will read it for your convenience. 6 minus 2, 2, minus 2, 3 minus 1, 2 minus 1, 3 within square brackets, minus 6 minus 2, 2, minus 2, 3 minus 1, 2 minus 1, 3 within square brackets. So therefore, we have to subtract A dash from A. Let us do it. Therefore, 6 half of 6 minus 6 is 0. Minus 2 minus 2, that is minus 2 plus 2 is 0. 2 minus 2 is 0. That is row 1. Now row 2, minus 2 plus 2, 0. 3 minus 3 is 0. Minus 1 into minus 1 minus into minus plus 1 is 0. 2 minus 2 is 0. Minus 1 plus 1 is 0. 3 minus 3 is 0. Hence, we have found a symmetric matrix as well as skew matrix. Therefore, it is 0, 0, 0. Therefore, given matrix A is equal to sum of symmetric matrix and skew matrix. Problem number 10. If A is equal to, within square brackets, 1, 2, 2, 1. B is equal to, again within square brackets, 2, 0, 1, 3. And C is equal to 1, 1 and 2, 3. Then calculate AB, BC, A into B plus C, and verify that AB plus AC is equal to A into B plus C within brackets. Let us do it. So, given values of A and B, that is AB, matrix multiplication of AB, we have copied both A and B. This is A and this is B. That is equal to, by multiplication, row 1 of A with column 1 of B. Therefore, it is 2 plus 2. And then again row 1 of A with column 2 of B. So that is 0 plus 6. Then row 2 of A with column 1 of B. That is 4 plus 1. And row 2 of A with column 2 of B. That will be 0 plus 3. So we get 4, 6, 5, 3. The next part is we have to find out BC in the same fashion. So vector B, matrix B is copied here, 2, 0, 1, 3. And C is 1, 1, 2, 3. Both are given matrices and they are of order 2 by 2. So we will multiply again in the same fashion. That is row 1 into column 1. So 2 into 1 plus 0, 2. Then row 1, column 2. That is 2 plus 0 again. Then again row 2 of B, column 1 of C. Therefore it is 1 plus 6. Then row 2 of B in the column 2 of C. That is 1 plus 9. Therefore it is, simplifying, we get 2, 2, 7 and 10. Now again we have to find out AC, because AC is required in this. AC we have copied, we have noted, again written A 1, 2, 2, 1. This is the matrix. Into C is 1, 1, 2, 3. So we have to do the matrix multiplication. Therefore it is 1, 1 plus 4, 1 plus 4. And the next item is row 1, column 2, 1 plus 6. And next is row 2 of A with column 1 of C. That is 2 plus 2. And again row 2 of A with column 2 of C. We get 2 plus 3. Simplifying, we get 5 plus 7, 4 and 5. Now again we have to add B plus C. So B is here 2 plus 1, C is 1, 2 plus 1, 0 plus 1 is 1, then 1 plus 2 and 3 plus 3. So we get 3, 1, 3, 6. So A into BC, we note A here 1, 2, 2, 1 and B plus C we have found here. So it is both the matrices are written here. That is A into within brackets B plus C. So we multiply now. Row 1, 1 into 3 plus 2 into 3. Then 1 into 1 plus 2 into 6. Then row 2 is 2 into 3 plus 1 into 3. Then again row 2 column 2. Therefore we get 2 plus 6. 2 plus 1 into 6. That is 9, 13, 9, 8. This is A into B plus C. Now AB plus BC we have to find out. Therefore AB we have calculated 4653 here plus AC 5745 it is written and added. AB we have added with AC. We get 9, 13, 9, 8. Comparing this equation A into B plus C and AB plus AC, we get VC that AB plus AC is equal to A into B plus C. Left hand side is equal to right hand. Next problem. If A is equal to within square brackets 2, 4, 5, that is in a column. 2, 4, 5 in a column. This is a matrix, 3 rows. 2 is one row, 4 is another row, and 5 is third row. So we have 3 rows and 1 column, and B is equal to 1, 3, 6. Verify AB dash is equal to B dash A dash. Here AB dash represents the transpose of matrix AB and B dash A dash are individual matrices, transpose of matrix B and matrix A respectively. Let us do it. Given A is equal to within square brackets minus 2, 4, 5 and A dash. So when we take A dash, we have to transpose. That is, rows should be changed to columns or column into row. So minus 2 becomes minus 2 here, A dash, 4 and 5. This column matrix becomes the row matrix here, one row. Therefore, B we have copied 136 and B dash is equal to 136. That is, a row has become column here. For B matrix, it is row 136 and for B dash, it is column 136. Therefore, we get AB is equal to multiplying A with B, we get minus 2, minus 2, minus 6 and minus 12. So this is the multiplication. 4 into 4, 12 and 4, 12 and 24. Then 5 into 5, 15 and 30. This is AB matrix. Therefore, we get AB dash. We have to transpose this matrix, product matrix AB. So AB dash becomes minus 2, that is row becomes column, minus 2, minus 6, minus 12. So minus 2, minus 6, minus 12. Second row of AB becomes column of AB dash. Therefore 4, 12 and 24. Then last row 5, 15 and 30. That is row becomes column 5, 15 and 30. Let it be equation 1. Therefore, we get we have to calculate BA dash. Sorry, B dash A dash. B dash is 136 and A dash is minus 2. Here we are calculating minus 2, 4 and 5. So we get 1 into minus 2, 1 into 4 and 1 into 5 in the first element. That is row 1, this is row 1, sorry, column 1, column 2, column 3. And then again 3 into minus 2, minus 6, 3 into 4 is 12 and 3 into 5 is 15. 6 into 2 is minus 12, 6 into 4 is 24, 6 into 5 is 30. This is number 2. So comparing, we see equation 1, that is AB dash is equal to equation 2, that is B dash A dash. Question number 12. Within brackets, square bracket, cos x minus sin x 0, sin x cos x 0, 0, 0, 1. Show that fx into fy is equal to fx plus y. Please observe here, the value of fy is not given. Only fx is given, function of x. And we have to prove fx into fy is equal to f into x plus y. Therefore, we have to follow certain steps as explained below. Please observe that fx is a matrix of order 3 by 3. So, the given matrix is written in as equation 1. Next step is to change x to y in 1 because fy is not given. Now we will take it as f into y. Substituting y, that is changing x to y, we get cos y minus sin y 0, sin y cos y 0, 0, 0, 1. This is simply substituting x as y, x to y. So this also is a matrix of the order of 3 by 3. Therefore, left hand side now of the question is fx into fy. So we will multiply equation 1 and equation 2. Therefore, we will substitute fx and fy as it is and move on to the next. Now we perform row by column multiplication. That is matrix to matrix multiplication. So it is simply cos x cos y. Therefore, first row, first column. So we will get cos x cos y minus sin x sin y plus 0. So this minus sin x is due to the second element. Then the next element is minus cos x sin y minus sin x cos y. And the last item is 0. It becomes 0, 0, 1. Then second row, first column, sin x cos x plus cos x sin y plus 0 into 0 is 0. The third column, third row is again multiplied in the same way. 0 into first row, first item 0, 0 into sin is 0 and all are 0. Then the second element also is 0. So third row, second column is also 0. Then third row, third column is, we have 0 into 0 is 0, 0 into 0 is 0, plus 1 into 1 is 1. The last item is 1. So we have performed row by column multiplication. Simplifying, we know the formula cos x cos y minus sin x sin y is, we know from our trigonometric knowledge, cos x cos y minus sin x sin y is cos x plus y. Similarly, minus if we take out cos x sin y plus sin x cos y is minus of sin x plus y. So 0 is as it is. Similarly here, cos x sin x cos y plus cos x sin y is sin of x plus y. And here it is sin x sin y plus cos x cos y is cos x plus y. And the remaining items are, the next item is 0. The last row is 0, 0, 1. Therefore, now we will change x plus y into y. That is x plus y to y. We get fx plus y is equal to fx plus y is equal to cos of x plus y, so minus sin of x plus y 0, sin of x plus y cos x plus y 0, and 0, 0, 1. In this equation, we simply put x into x plus y. Hence, left hand side is equal to right hand side. Question number 13. If a is equal to 3 minus 4, 1 minus 2 within square bracket, then prove that a to the power of n into equals within square brackets 1 plus 2n minus 4n, n and 1 minus 2n, where n is a positive integer. It is given. So matrix A is given 2 by 2 matrix, and we are required to prove that a to the power of n is equal to 1 plus 2n minus 4n, n and 1 minus 2n. Let us solve it. We have to prove the result by principles of mathematical induction. Therefore, given we are required to prove a to the power of n is equal to within square bracket 1 plus 2n minus 4n, n and 1 minus 2n. Therefore, step 1 is we have to put n is equal to 1 in this equation 1. We get 1 plus 2 minus 4, 1 and 1 minus 2. That is equal to 3 minus 4, 1 minus 1. Which is true for n equal to 1. That is, if you compare a and this equation after substitution, it is one and the same. Step 2 is put n is equal to k. Therefore, if you put n is equal to k, we get a to the power of k is equal to 1 plus 2k minus 4k, k and 1 minus 2k. Let it be equation 2. So, step 3 is to prove the result is true for n is equal to k plus 1. Now, we are written for k and we have to prove for k plus 1. So, we have to show that n is equal to k plus 1. Putting n is equal to k plus 1 in equation 1. We get, this is the equation 1. A to the power of k plus 1 is equal to 1 plus 2 into k plus 1 minus 4 into k plus 1, n in k plus 1, 1 minus 2 into k plus 1. Therefore, simplifying, we get 3 plus 2k minus 4 minus 4k, k plus 1 and 1 minus 2k. Sorry, minus 1 minus 2k. That is, let it be equation 3. Now, a to the power of k plus 1 is equal to ak. Again considering, simply from our mathematical knowledge, we know a to the power of k plus 1 is equal to a to the power of k into a. Therefore, we will write it again. A to the power of k is here. That is from equation 2. We will substitute, and the given matrix is also written 3 minus 4, 1 minus 4. This we have copied from the given data, that is 3 minus 4, 1 minus 1. So now performing row and column multiplication. So we get 1 plus k, 2k into 3 and minus 4k. That we get 3 plus 6k minus 4. Similarly, first row, second column, that is minus 4 minus 8k plus minus into minus plus 4k here. Then second row, first column, k into 3 is 3k plus 1 into 1 minus k. Therefore, it is 1 minus 2k. It is written here. Therefore, second row, second column, we get minus 4k into plus minus into minus is minus, plus into minus is minus 1, minus into minus is plus 2k. So this is row column multiplication of ak into a. So simplifying, we get 3 plus 2k minus 4 minus 4k, 1 plus k minus 1 minus 2k. Hence, which is same as 3, what we have proved it, which is same thing. Hence, this result is true for n equals k plus 1. Hence, by the principle of mathematical induction, the result is true for all positive integers. So, we have completed 5 marks questions, whatever is given in by the PU examination board. Please practice it again and again. It is very simple. If you find it difficult, please perform repeatedly on simple problems. Thank you.